We everyone, this is a video about the BRM project which we are supposed to do. So the template for the same has been shared by sir, and beginning with the template we have our abstract. Abstract is basically a short and concise summary of your project where you talk about your topic, what was the motivation for you choosing this topic, and what are the objectives, what is it that you wish to achieve for this topic, and the conclusions, any findings and major insights which you found while conducting this research study. Coming to the introduction, you can talk in general about your topic. For example, for your particular topic, what were the past things which happened, what are the current things which are happening, and what is it that might happen in the future, why it is important, why we believe that this is something important to be done. You can talk about how did you collect your data, what type of data you collected, and maybe you can include your research questions also. You can include your dependent and independent variables, and the questions can be included in those. Now, talking about the literature review, we chose 5 independent variables for our literature review. It can be 4 or 5, depends on your questionnaire or anything. Yeah. So talking about the literature review, we already wrote the summary of each individual article recently. So now what we are supposed to do is basically in our literature review for each of the 5 independent variables, we are supposed to write one short paragraph for each independent variables. That paragraph is basically a synopsis of the most important findings and insights from each of the articles which are there. For example, if my independent variable is comfort, our topic is customer satisfaction while using the public transport systems. So for example, this article, if we talk about, we comfort is an independent variable, and this article it talks about, it aims to create a combined bus comfort model which considers external elements such as vibration, noise, acceleration, and thermal comfort, etc. So we can say that this article takes into consideration these things, and these things are important while determining the comfort, which in turn leads to adequate customer satisfaction. Talking about this article talks about, for example, the driving technique with objective measures of accelerations. So again, uh, in that paragraph, you need to mention the most important findings of all of the 5 articles, and that is what you're supposed to do in your literature review. Coming ahead to the methodology. Methodology is basically, the data analysis procedure which you will be doing, the data tools which you will be utilizing to analyze your data, with the data tools being, for example, IBM SPSS statistics or the JMP software. So you need to say that we in the methodology we did these tests, multiple regression model, parametric and non-parametric tests, which we will be discussing further. So it is basically an overview of your tests which you will be conducting in your study. Now coming to the data analysis part of it, so the first part in the data analysis is the descriptive statistics. Descriptive statistics is basically, it captures the gist of the main elements in your research study. For example, a very common, part in all of the questionnaires will be gender, let's say. So for gender, what you can include in descriptive statistics is basically, the frequency distribution. Like there are 60 men and 40 women respondents in my survey, and let's say if you asked about the age of the respondents, so what can be done is basically a percentile distribution can be created. Like for example, at the 50th percentile, which is my median age is, let's say, 25 years. So we can say that my median is 25 years, at the 25th percentile it's this, and at the 75th percentile it's this. Maybe, not necessarily. You can also calculate the interquartile range. Now talking about the model testing which is supposed to be done. So for the model testing, what is supposed to be done is when you get your responses in an Excel file, like you export your responses into an Excel file from your Google Forms. So your responses at the beginning may look something like this. For example, for each of the questions, you may have responses on the basis of Likert scale. Like for our group, for our independent variables, we asked only Likert scale questions. It might be also that, for your independent variable, you may have asked some question with categorical responses, categorical slash nominal responses to it. This is completely fine. Now talking about the multiple regression which we are supposed to do. So first of all, the first step what needs to be done is this data needs to be modified. So while talking about, for example, if I consider this question, how satisfied are you with the reliability of the public transit schedules, including the accuracy of arrival and departure times? So we had a Likert scale responses for this, which, from lowest to highest, which being very dissatisfied, neutral, satisfied, and very satisfied. So what we are supposed to do is we, on a Likert scale from 1 to 5, we give the lowest, which is very dissatisfied, a rating of 1, and the very satisfied option which is there, we give it a rating of 5. So basically on the basis of this you modify your data. It can be anything, not only satisfaction. For example, here it is about convenience, here it is about time, and so on. It completely depends on your data. When you do this, your data will look something like this. So these are basically the responses converted into a Likert scale form. One thing which could be done is you can highlight your questions in different colors to recognize your independent variables for more easily. For example, these questions which are highlighted in gray, this is the independent variable of efficiency which we have chosen. So with that being done, now what we are supposed to do is we need to do one more thing, is the summated scale response. For example, for each of the independent variables, I have three questions. In the summated scale, what we do is we create one common column for all of the variables. For example, efficiency, there is one column, comfort, there is one common column, customer service, there is one column, etc. So when we do this, what we are supposed to do is for each of the three questions, we are supposed to calculate the average of those Likert scale responses. For example, if we talk about this response of 4.33 for our efficiency, what basically was done is basically it is the average of these three numbers, 3 plus 5 plus 5 divided by 3, which comes out to be 4.33. So we do this for all our variables, and this is what our output looks like, the final output. Now there will also be a question which you might have asked, about your dependent variable, like a very general question it can be. For example, for our survey, for our dependent variable, we ask the question, what is your overall satisfaction with the public transportation systems? And these were the responses, the dependent variable responses. So what we are supposed to do now is regression, which is pretty basic, which we have done recently for our SIDM projects also. So after doing my regression, basically if I do my regression, my input y range will be the j column and my input x range will be all of my independent variables. After doing this, again, pretty basic, the outcome, this is my regression output. You can analyze your model on the basis of these three things: multiple R square, adjusted R square, the significance of the variables. If you want to talk about individual variables, you can look at the p-value. If you wish to write the regression equation also, you can do so with the help of your coefficients and so on. So this is basically about the summated scale multiple linear regression which we are supposed to do. Now talking about the parametric, one more thing which needs to be done, the references, the hypothesis. Please make sure that you write the hypothesis in your regression, which was written in the document also, the null and the alternate hypothesis for your regression. Now coming over to the parametric and the non-parametric tests. So with that being said, parametric and non-parametric tests, This image you can use as a reference. So on the left hand side are the parametric tests. These are the tests which which we have conducted already. Like parametric tests are something which we have already done in our SIDM project also. Now the counterparts, the opposite counterparts of these parametric tests are the non-parametric tests. The main difference being that in the parametric tests we assumed our data to be normally distributed, but in non-parametric tests that is not the case. So yes, that is the main difference. Now, if we talk about how to do these tests in JMP, since a lot of us have the JMP license version. So for example, if I wish to do the one sample t-test, this is one of the files from the sample data folder in JMP Pro. So what we are supposed to do is, let's say I wish to do a one sample t-test on the horsepower. Now again, to determine whether my data is normally distributed or not, I go to distribution and I check horsepower. So after seeing this, we can say there are a couple of outliers, and we can determine that visually we can say that our data is not normally distributed. So now to do a non-parametric test on this, we do distribution, we click OK, and now the non-parametric test for this is test mean. Now if you need to check the box for the non-parametric test, and you can hypothesize your mean. For example, my mean here is 130, so let's say I consider my mean to be 132. So this is my outcome, and for the Wilcoxon sign rank test you can interpret your results accordingly with the variable which you have chosen. Now, one thing to be kept in mind is that here we are not our hypothesis. There's basically that there is no specific difference between the means, which are the null hypothesis, and the alternate hypothesis was that there was some specific difference in the means. Here we talk about, in non-parametric tests, we talk about the central tendency. So what we do is, in our null hypothesis is, in this case I can say, is that there is no difference in central tendency in the there is no statistical difference in the central tendency, and the alternate will be that there is some statistical difference. Now coming ahead to the talking about the independent sample t-test, which is your Mann-Whitney u-test or the Wilcoxon rank sum test. I would like to explain this with my own data set, which is for the summated scale. So let's say if we want to compare the perceived value of comfort for men and women, again the first step which we would do is check the distribution of it. We choose comfort in our y column, and we are checking it against our gender. On doing this, we see that our data is not normally distributed. So again, here what's supposed to be done is, basically we'll go ahead with our non-parametric test. To do that, we go to this fit y by x. In our y response is the comfort. In our x factor we choose gender. So this is what the output looks like. So now to do the Wilcoxon test, which is and it is the Mann-Whitney test and a Wilcoxon test are pretty much similar. They Wilcoxon is just for the independent samples. So on doing so, while clicking this Wilcoxon test, this is what our output looks like. So again, when you are writing this output in your Word file, please ensure that you write the appropriate hypothesis, because it is very important. In my case, the hypothesis will be, my null hypothesis will be, there is no difference in terms of central tendency between the main men and women groups in the population, and alternative will be that there is a difference between central tendency of comfort between men and women. So this is my Wilcoxon test, the independent sample t-test. Now the next test which is there is the ANOVA test, which is the Kruskal-Wallis test for non-parametric, if my data is non-parametric. So to do this, I would like to explain this with the help of this file. Yeah, for example, if we wish to compare, the horsepower of vehicles and their country of origin. So again, what we do is same thing, distribution. We go horsepower by country, by each country. So on looking at it, we see again our data is not normally distributed for all the three countries, US, Japan, and other countries. So now what we do is basically we again go to fit y by x, we go to horsepower, and we go by the country. On doing so, we find this as our output. Again, our non-parametric test this time will be the Kruskal-Wallis test and not the Wilcoxon test, because there are more than two groups. We have the Japan, US, and other countries. So in this case, as you can also see, the test which was there is only the Kruskal-Wallis test. So again, for a Kruskal-Wallis test, the hypothesis is, write the optimal hypothesis for your Kruskal-Wallis test. Yeah, so make sure to include your, hypothesis. In this case, my hypothesis will be that the central tendency of horsepower for all the three countries are equal, and my alternate hypothesis will be that my central tendency of horsepower for all the three countries are not equal. So again, the main difference between the Wilcoxon test and the Kruskal-Wallis test is the number of groups. So with that being said, that is the basic gist of the parametric and the non-parametric tests which you will be doing. Yeah, one more thing which you could do is categorical tests. Sorry, not categorical tests. Tests containing categorical variables. For example, again, pretty basic, the chi-square test. For example, for a car physical data, to I can do the test for, the country and the type of vehicle which is there. So again, this is my chi-square test, pretty basic. We have done it last time also. It depends completely on your data, on the questions which you have asked in a questionnaire, and on the basis of it you can conduct the tests. And yeah, coming to the conclusion is basically, find out maybe some learnings from the project, some findings from the project, and how we believe that these results are optimal. Maybe you can write about some of the future scope, maybe some shortcomings which you faced during the project, and so on. So that will be all. Thank you.
So now we are seeing the exploratory factor analysis which we are supposed to do. So first of all, if you don't have the IBM SPSS statistics software, make sure to download it. If you guys have not downloaded it, it has a free 1 month subscription, so you can download it. Now you need to import your Excel file. You can do so by importing it from here, import data in Excel. And what you're supposed to do is make sure to import the sheet which has the modified data as we saw previously, which for all the independent variables, all the questions are in the form of Likert scale responses, in the form of numbers, basically scaled responses. So what we are supposed to do now is basically to do an exploratory factor analysis. We'll go to analyze, we'll go to dimension reduction. After that, we will choose factor, and in factor, we will choose all of our responses, for all the independent and dependent variable responses which we have here. And the further process has been given in the template which was shared by the sir. And one thing which you could do is this thing, the coefficient display format. When you select suppress small coefficients, so basically what it will do is for the correlation coefficients, the values which are below zero point 0.6, they will not be included in your correlation set. So doing that, click continue, and then you can click OK. So after doing selecting OK, I have already done the factor analysis on top. So this, I'll just delete this whole thing. Now, this is our factor analysis test. So basically, the first test which you see here is the KMO and the Bartlett's test. So what this test is basically, it tells you about the correlation between the variables for factor analysis. This, determines whether your variables are strong or suitable enough. Suitable would be the right word, whether your variables are suitable enough to, you know, to go ahead for the further factor analysis. The the value for this, the value for the KMO test, like we take 0.05 for as our alpha value. Similarly, for the KMO test, the value is 0.7. So basically, if your value is above 0.7, so you can say that yes, my variables are suitable enough, strong enough for factor analysis. Now, going ahead, these are the initial responses for this, and this is just for information like how much, the data is suitable with the response, like 65%. We don't need to pay much heed to this. Coming to the total variance explained, so as the initial eigenvalues, we tick the box while, editing and ticking some boxes while doing the exploratory factor analysis. So basically, what we did was we selected that our eigenvalues initial will be greater than 1. So on the basis of this, all the values above than 1 have, will be chosen as our factors for our components, and the values you see here below 1, they are not chosen for our factors. So on the basis of the initial eigenvalues which are greater than 1, we can see that if we count the number of rows, there are a total of 5 factors on the basis of initial eigenvalues. And to determine the variance extracted from each of these factors, say you can probably say this with the help of extraction sums of squared loadings and rotation sums of squared factors. So talking about the loadings, the factor loadings, which we see extraction sums of squared loading, rotation sums of squared loading. What this is basically is, this represents the correlation coefficient. It is a correlation coefficient between the observed variables and the new factors which have been created. Their values range from basically -1 to 1 for the loadings. Now, moving ahead, what we are supposed to do is, we can see yes that we have 5 factors which are created. Next, where we need to go is the rotated component matrix. Here we can see yes there are 5 factors, but the final factors which we see here are 4 factors which we can see. Like if I see my factor 1, so these 3 values are aligned together, basically 2 questions for comfort and 1 question for safety and security. So these underlying factors, these three, like 2 questions of comfort and 1 question of safety and security, they have an, underlying factor. This is an underlying factor which leads to customer satisfaction. So this is one factor, this is another, and similarly they are individual here. So these two play, we can say that they can play a crucial role in determining, customer satisfaction. Now, we discussed the KMO and the Bartlett's test. Now, further to do the Cronbach's reliability test. So, as we discussed before, the KMO and the Bartlett's test is basically to understand the suitability of your factors, whether they are correlated well enough to, go ahead for our factor analysis. For our Cronbach's alpha test, it will tell us about the internal consistency of the scales. So to do that, we go to analyze, we go to scale, reliability analysis, we choose all of our variables, dependent and independent. We go to statistics and select item, scale, and scale if item deleted. We click continue and we click OK. Since I have already done the test, this is the output which we will be seeing. Again, like the KMO and the Bartlett's test, the Cronbach's alpha test also has a measure. So if our that measure is also zero point 0.7, So again, if our Cronbach's alpha value is greater than 0.7, we can say that yes, our scales have, a good internal consistency. So this is our Cronbach's reliability alpha test. And now moving ahead with the average variance extracted. To calculate that, we go back to our rotated component matrix. So we see that one of my factors is this, like I'll call it factor 1 for the time being. And we see there are three values. Basically, what we do is double click on this and copy these three values. Now you can do it on your existing Excel file, or you can make a new one. So this lambda, which is my factor loading, you paste the values here, you sum all of these values, and here you do the individual square of your lambda values, lambda square. And going ahead, this epsilon value is 1 minus lambda square. So for all the three columns, you submit all the three columns, and to calculate your average variance extracted, basically your n is basically the number of factor loadings, which are three, and to calculate the average variance extracted, you basically divide lambda square divided by n, which gives you your average variance extracted for factor 1. So one thing, yeah, please make sure to name your factors, give appropriate names to your factors. And yes, that is all what is about your exploratory factor analysis.